Hello everyone, thanks for joining us today. Today's subject is about science of cracks, and our guest is Dr. Selda Oterkus from Strathclyde University. And Dr. Selda Oterkuş is a senior lecturer in Naval Architecture and Ocean and Marine Engineering Department at the University of Strathclyde, based in Glasgow. Her main research interest is about offshore and subsea structures, fluid structures, and damage modeling and their physical analysis. And she is also vice director of the world's first PeriDynamics Research Centre. And thanks again for her to joining us today. And I would like to just say thanks to everyone who is attending today. And please, you can start now, Dr. Selda Oterkus. So, floor is yours.
Thank you very much, Önder, for the very kind introduction. Now I'll share my screen. Hello, everyone. My name is Selda Oterkus. I'm working as an associate professor at the University of Strathclyde at Naval Architecture, Ocean and Marine Engineering Department. And today, my talk will be on science of cracks. So before I start, I would like to briefly introduce myself. I'm from Izmir, and Izmir is the west coast of Turkey, and I did my undergraduate degree at Dokuz Eylül University at this very nice city, in mechanical engineering department. And after I finished my undergraduate degree, I decided to go for a master degree. Then in the same city, I did my master again in the mechanical engineering department. Then after I finished my master degree, I decided to have a PhD. And for that reason, I applied for a PhD position at University of Arizona. And I was accepted, and I moved to Arizona after deciding for a PhD. And after I finished my PhD, I decided to have an academic position, and I started looking for universities for opportunities. And then I was offered a position from University of Strathclyde. And then I moved to Glasgow in 2015. And since then, I'm working as an academic at University of Strathclyde in Glasgow. So I'm a structural engineer. So as a structural engineer, we can be considered as doctors of structures. And when we say structures, they can be anything that you can imagine. It can be a ship, it can be an airplane, it can be a car, or even our bodies. We can be all consider these as doctors of structures. We can consider all these as structures. And when these structures are subjected to external loading, they start deforming. As the structures deform, they start feeling uncomfortable, and their stress level increases, actually just like ourselves. When we are loaded with too much stress, we also feel uncomfortable. And if the stress level increases too much, structure fails as a result of cracks. And catastrophic failures can occur. Which means that we need to take some actions to prevent these. So, as a structural engineer, we need to consider how can we predict these cracks before they actually happen for our safety. We need to understand why these cracks occur, where and how they start, and how they propagate. So we want to understand the behavior of the structure during the damage process. And if we can do this, maybe we can suggest some solutions to prevent or to minimize these damages, to avoid catastrophic failures. In old days, people were using theoretical calculations for finding these damages or for finding these cracks. They were just simple hand calculations, but they were mostly limited with simple cases. But instead, we can use numerical models. Today, we have computers, and we can use computers to make crack predictions for very sophisticated crack problems. For example, by using computers, we can simulate what happens if a bullet hits to an armor material, which is very important for the safety of our soldiers, so that we can take necessary actions. Or what happens if a missile hits a concrete material? We want to know. We want to know this so that we can take necessary actions. Here, these are our computer simulations, and you can see what can happen, what type of damages can happen. And we need to look for methods to predict these damages. An suitable method can be what we call PeriDynamics. It's such a method, it's such an approach that can be used for analyzing cracks. Just like medical doctors can help you to handle your stresses, we can help your any type of structure to prevent from cracking by using PeriDynamics. But what is PeriDynamics? In order to better understand what is PeriDynamics, we need to look at two concepts: cracks and local, non-local behavior. Although we don't realize, cracks are actually part of our lives. And in most cases, cracks are the things that we don't want them to happen. For example, if you buy a brand new phone, and if you drop it on the floor, you will have these cracks. And it will be very annoying to use such a cell phone. Or you have a nice cup, if you drop it on the floor, again, you will have cracks. So maybe you may not be able to use this cup again. So as you see, these are things usually we want to avoid. However, sometimes you want to have cracks. For example, if you want to enjoy a chocolate bar, first thing you need to do is you need to open the package. And to open the package, you need to tear the package. So you need to create a crack. Once you open the package, your teeth needs to split or the chocolate bar into smaller pieces so that you can enjoy it. So it is sometimes fun to have cracks. But of course, if you keep enjoying the chocolate bar without cleaning your teeth, you may create another damage on your teeth. So you need to kind of know what can happen before they happen. Or your skin. If the weather is too cold, if you don't take necessary action, maybe you may have cracks on your hands too. So cracks can be anywhere. So they are very much involved in our daily life, although we don't realize them. Now, the question is, as engineers, can we predict when and why the cracks will occur and how they will evolve? So, in order to better understand the difference between the traditional approaches and PeriDynamics, we need to look at local and non-local concepts. Because the traditional approaches are based on local concept, but PeriDynamics is based on non-local concept. And the definition of local concept was introduced long time ago by Aristotle. He mentioned that in order to move an object, you have to push it, you have to touch it. Although it is correct, it's not complete. Today, we know that objects that are far from each other can still interact with each other. In other words, if you want to move an object, you don't need to touch it, just like gravitational force. For example, here, Newton was sitting next to a tree and the apple fell on his head. But the ground didn't touch the apple. It just fell down because of these non-local effects. There is a non-local interaction between the apple and the ground, and it fell on the ground. And PeriDynamics is based on this non-local concept. And the word PeriDynamics is coming from a Greek language. Peri means surrounding, which represents the non-local interactions between different objects. And dynamics means force between these interacting objects. And as engineers, we would like to simulate, we would like to know how our structure behaves. For that reason, we need to create mathematical model to represent our real structure. So what we do, we subdivide our structure into small parts so that we can simulate, we can represent the real structure in a computer. And we call this technique, these techniques are traditional methods by subdividing our regions. And when we subdivide into smaller parts, these parts only interact with its nearest neighbor. This is something like you have 4 neighbors and you are only interacting with them. So this is just a representation of traditional methods. By using traditional methods, you can find how your structure will deform under loading conditions. And here are some other results for you to have an idea how PeriDynamics can be used. Offshore structures, they are inside the sea and they are subjected to harsh marine environment. So anything can happen. You see here, because of harsh marine environment, we can see the damage can occur in these platforms. Again, by using PeriDynamics, we can predict this behavior. Or what happens if a ship hits to your platform, because these platforms are in the sea. Again, by using PeriDynamics, we can predict what can happen. As you can see, we can investigate many different challenging crack problems by using PeriDynamics. Because of this reason, we established the world's first research center on PeriDynamics here at the University of Strathclyde. And we are hoping that we will continue investigating many more different cracking problems. Thank you very much for your attention.
Thank you very much for this very nice presentation and very clear. I think everyone can understand if they are engineer or not. So this is a very sophisticated presentation, but it is very easy to understand, I think. So now I would like to ask everyone, if you have any question, you can ask. And I think Muhammad Burak asking one question, if he is on the line.
Hello.
Hello.
Dr. Öterkuş, thank you very much for your presentation. and it's quite understandable and easy for everybody. Actually, my question will be quite dummy because I'm not working on this subject. As I understand from your presentation, PeriDynamics is a way to model to particles in kinematic level. So my question is about what's the differences between the other Lagrangian models, such as discrete particle models? And my second question is, can PeriDynamics coupled with the other Lagrangian models for elasticity problems? Thank you very much.
So the difference between PeriDynamics and traditional approaches is we usually use traditional approaches for predicting deformation of the structure. But by using PeriDynamics, we will have chance to predict these damages. And other methods may be numerical based, but PeriDynamics is physics-based approach. It's based on non-local concept, and it is very suitable for this behavior. And we don't need to put any external criteria, we don't need to lead the crack. They just happen naturally. So we don't need to put extra criteria for that. And we can couple PeriDynamics with other methods as well. I think that was your question. Not just predicting damages in structures, but we can also, let's say, predict with, couple with other solvers. For example, you want to couple with finite element model, or maybe you can combine all other fields in the same framework. Right now, what we are doing, we are solving, for example, fluid mechanics equations with PeriDynamics. We can couple them in the same framework. Does that answer your question?
Yeah, thank you very much for your answer. Just my question is like, for example, we can apply for different models for the particle modelings, fluid particles modeling, and I want to couple PeriDynamics with these particle collision models for fluids. I mean, I want to make a simulation, coupling of PeriDynamics and the other fluid particle models. Is it possible to do this?
Exactly, it's possible. Actually, our paper has recently accepted. It will be online soon. We use PeriDynamics for fluid structure interaction. Although we also simulate fluid by using PeriDynamics, but if you want, you can use smooth particle hydrodynamics for simulating the fluid, and you can use PeriDynamics for simulating the structure. So you can couple them.
Thank you very much for your answer.
Yes, thank you. Thank you very much for your questions.
Thank you very much, Burak and Dr. Selda. And any other question? If you have, you can type or just unmute yourself and go on. If you don't, I would like to ask one question about the PeriDynamics Research Centre, because today Dr. Selda and Dr. Erkan is here. So this is, I think, an opportunity to ask. It is the first and only research center about this subject, and you have a quite big group of researchers and strong people. And I'm also doing PhD at the same department, but not the same research group. Could you please explain what is the benefits for the upcoming researcher, or the kind of collaboration for them and for their projects, and just short explanation of the research center, please. Thank you.
Thank you. So, as you said, it's the PeriDynamics Research Center. It's the first center in the world on PeriDynamics, and we have many researchers working on this area, and maybe they have working on many different problems. So the advantage of having this center is, when you come to our center, you will see other people working similar topics. You will have similar concerns. You will have similar problems. We are very like a family. We call it PDRC family, as you can see in the slide. We are kind of interacting with each other, supporting each other if they have any issues. So you don't feel that you are the only one working on your topic. I think it's a very good advantage for the newcomers.
Thank you. Maybe We have another question. Just before this question, I can pass this same question to the Dr. Erkan Öterkuş if he has something to add.
Thank you, and that's all for your question. So basically, I think Selda gave a pretty decent answer. So, so as she mentioned, basically, there are many researchers working on aerodynamic related problems within our center, and basically the main advantages, although they are looking at different problems, the main concept is the same, so that they can support each other. So if somebody is trying to find out a particular issue, he can or she can has the opportunity to discuss with other team members. I think that's a kind of a pretty good advantage, so that you can move much faster rather than trying to resolve this issue on your own. And also, probably another thing that I would like to highlight is, as you can see, we can encounter cracks in many different fields. So it also brings this interdisciplinary type of basically kind of concept to the center. So it's not just limited to a particular area. I think it's very exciting in the sense that basically we can explore problems that all of us are facing in many different areas. So I think this is also one of the biggest advantage of our center. So basically, as person who may have coming from a very different background, actually he can or she can work at our center. So because, as I said, cracks are everywhere, and as long as the person is very interested in cracks, he or she will find an opportunity to work with us.
Thank you. Thank you very much. So we have two more questions now. One from Murat. If he can ask this question, we have time to answer. Murat, are you there?
Hello, can you hear me?
Yes, we do hear you.
First of all, I want to say that it was a very useful presentation for me because I'm very interested for the fracture mechanics until my master year. And also right now I'm studying on the pressure vessel system. And also one chapter of my thesis is about the fracture mechanics. And also I have modeled for the corner crack for the cylinder intersection on the nozzle part. For this reason, I want to ask, in the literature, generally researchers use the solver to find stress intensity factors for the crack propagation analysis. And I want to ask that, does PeriDynamics Research Centre has a solver or just use the mathematical models?
Sorry, maybe I didn't understand your question very well.
Generally, I used some solvers to find stress intensity factors for the crack propagation analysis. And I'm just asking you, does PeriDynamics Research Centre has a solver for this problem, or you just use mathematical models?
So we have, we are generating, maybe if I understand the question correctly, when we are using PeriDynamics, we are using our own solvers. We are generating codes. We are using MATLAB or Fortran. We are generating our own codes. But also there's a PeriDynamics book, for example, which was written by Dr. Erkan. In that book as well, there are some sample benchmark cases.
I'm asking this question because generally we use the simple models, but sometimes we have to use the complex model. And for this, sometimes to determine to crack emission and crack propagation is very hard for us. And for this, sometimes mathematical models is not basic for us. For this, we have to use the solvers. If do you have, if it's possible, I want to see you on your office, or because I need to find I need to find a new solver because I have failed for my new model.
Sure, definitely. If you'd like to discuss, of course, you're more than welcome. Maybe.
Okay. Thank you.
Have a meeting. Yes.
Okay. Thanks so much.
Thank you.
And we have another question from Oğuzhan. He just typed it. If you want, you can ask, or I can read it for you, Oğuzhan. Yes.
Okay. Hello, everyone. Thank you very much for the presentation. It was wonderful. Is there any commercial software to do PeriDynamics approach, or are you developing your own code to check the cracks?
So currently we are developing our own codes, but what we are doing also, we are cheating commercial softwares. Commercial software doesn't know that it's doing PeriDynamics, but we can, of course, we need to calibrate the PeriDynamic parameters. So in an academic way, we are cheating the software, and we can use PeriDynamics as well.
Actually, my question is, for instance, if I would like to do a PeriDynamics calculation in one of the commercial software, what do you do exactly? Like, do you add a patch in the software, or
so,
how it works actually?
So normally the classical or traditional methods, you need to put material property, let's say elastic modulus or Poisson ratio into your software. But PeriDynamics, we have PeriDynamic parameters. So there is no input that you can put in directly in the commercial software. But if you somehow calibrate the existing parameters in the commercial software, and you can link them with kind of springs in a basic way, you can use commercial software. Actually, we have some publications on this. Maybe you can take a look at it. It may be.
Yeah, I will. So that's all my question.
Thank you.
Is there any more question?
I have a question.
Okay, go on, Kadir.
Thank you for your presentation, Dr. Öterkuş. I'm not in this kind of discipline, engineering discipline. I have a different question about the cracks. Is there any differences between organic and inorganic materials in aspect of the cracks? If so, what's the main differences? I mean, for example, bones, it's actually inorganic, but it's the biological structure. But the fracture is very big problem in aspect of the biological structure. Is there any differences, or can we model it for using the PeriDynamics? Thank you.
Thank you. Thank you for the question. So what we are doing, where, as I said, we are simulating this structure. So for that, we need to know what material is used for that structure. It can be polymer, it can be steel, or anything composite, let's say. So if we know the material, we need to make the material model in the PeriDynamic framework. So and if we have the PeriDynamic model, we can simulate any material you can imagine. It can be bones also. We can predict the fracture in bones. You just need to have the correct material model.
But there is other problems about the modeling, I think, because there is a flexibility, there is the thickness of the bone and location of bone, stress level of bone. How can we model this kind of all of things together?
So as I said, first we need to understand the material. We need to make the PeriDynamic model for that, because each material is different. And after that, we need to understand the loading, what type of loading the bone is subjected to, because loading is also very important. Maybe your expertise can tell us the loading, for example, the bone can be subjected to. And we can apply this loading on our material, bone material, after we model the bone, of course.
Okay, thank you so much.
Thank you. Thank you very much.
Thank you, Kadir. So is there any more question? So I think we had nearly the time finished, but before we finish, I would like to add maybe one more question regarding the upcoming students, because lots of students trying to do PhD or MSc program. Are you planning to open one MSc program, master program for that subject? Or this is the first question, maybe it could be good for the upcoming years. And another one is, do you have any general suggestion for this upcoming students for PhD or the other subjects, because you have a quite good experience in USA and UK itself? So yeah, this is few questions and remarks if you can give before we finish. Thank you.
Thank you. So it's the first time we have this question to have a master degree on PeriDynamics. Actually, it can be a good idea. Why not? Maybe in the future we can consider this. I think we didn't think about it before, have this label on the master degree. I think it will be a good opportunity. So for upcoming students, if they want to do a PhD abroad or in Turkey or wherever they wish to do, I think it's important that they study the topic that they want to start, the work that they enjoy. First, they need to like what they are doing. I think they need to decide what is the topic that they are good at, what they want to study and enjoy. And then once they decided, they can start searching for universities, or actually for researchers, or professors. They can start searching for them to see if that their field then is suitable for them. I think that can be one thing to do, and they can maybe contact with them. If they want to do a PhD, this is my expertise, these are the fields that I'm interested in, can we work together? And they can try to find out a way to work with the professors. I think emailing and contacting with them is a good thing, because not all the time PhD opportunities are available online. So it's better just to send an email and see if they can find any opportunity.
Maybe one last question from my side as well. So, and new startups and the new business plans developing every day, and the companies also collaborating with the Strathclyde University very well. So how do you welcome them, and do you collaborate with the companies, and maybe our graduate, because we are as an ATAS, we are the group of students and they graduate together. Probably when they graduated, they're gonna start new businesses. So this might be a good question, and for them, for the future, do you have this kind of collaboration, or do you suggest them to contact with you for the future collaboration for the industry? Thank you.
Thank you. So sure, as a Strathclyde University overall, we have all good links with the companies, and of course, as a research group as well, we have also our personal links. So sometimes these links can be a PhD work as well. Sometimes PhD is directly linked, directly sponsored by a company. So they directly work with the company, plus they are trying to solve their problems. I think if they can find such an opportunity, that's also good. Or after they finish their PhD, if their project is related with the company, again, they can start making links with them. Or sometimes we apply for proposals look for funding for students or for researchers. Again, when we are applying for proposals, again, it's another collaboration opportunity for us with the companies. Of course, they should feel free to contact with me or with ourselves. It will be a good chance for them as well.
Good chance. Okay, thank you very much for today. And
thank you very much.
We are honored to be host you in this platform. And thanks everyone who's attended today and who gonna watch in the future from our YouTube channel. So we're gonna give the details about the research center and the atas down to this description of this video. So thanks again, and have a nice day.
Thank you.
Everyone.
I have one.
My honor. Yes.
Yeah.
I have one last question actually.
Yes. Yes, also.
You know, in accident scenarios of cars are quite popular actually, like Euro NCAP tests or some bird interaction during takeoff planes, etc. So have you had a chance to do such tests, or what kind of examples can you give about the PeriDynamics? Last time you just showed one jacket, offshore jacket, which is touching to the one of the vessel, but if you may give some examples to understand the approach of the industry as well, because probably you are also interacting with the industry, so there must be some realistic scenarios, or I don't know, some demand from the industry maybe.
Sure. Sure. As I said, we are in contact with industry, and we are trying to solve their problems. It can be any like kind of riser industry or any other, for example, defense industry. We are trying to solve their problems. We are trying to predict the damages, or it can be ship structures, for example. I show you, but I didn't present all the results in here. Or it can be nuclear industry as well. Before we work with them, or electronic industry. It was related with the Samsung company, for example. So we have many different links with them, and we solve many different problems. I think it's also a good chance for us to interact with them and try to solve their problems so that we can contribute to them.
Thank you very much.
Thank you.
Very much again.
Thank you.
And have a nice day. If you would like to add anything, you can, but otherwise we can finish it for today.
Sure. Sure. I just want to thank to all of you for this nice organization and for inviting me to give a presentation. I think it was an honor for me. And thank you very much.
Thank you very much, and thanks for today. Have a nice day.
Thank you.
Thank you.
Thank you.
Bye.